Hi, this is Straight A Programming. I'm going to talk about the exec functions. These can be used with process creation. They don't have to be, but it's in creating processes, you oftentimes want to run a program in a separate process. So let me go over the code. So the exec functions include all of these. I'm going to demonstrate a few of them. They're very similar. You put in the it runs another program. So that's basically what this does. It'll take the full path to the file. So it's easier if you could put the executable file in the same directory that you're working with. Um, Arguments and there's different ways that you can pass in these arguments. So like say you have some command line arguments, you can put those here. And the first arguments is by convention. Argument zero is the name of the file, the executable file. So um like this one is a pointer to a file, and this one's different because this searches for the executable file in the path variable. So xlp is a convenient one when you know the executable file is in the path variable. These have vectors. Like I said, argument zero is going to be the executable file. So these are the man pages for this, and so you can play around with this and pass in different arguments to see how they work. Um, you don't have to create a separate process to use them. Um, but that's one way to do it is you create a separate process to run a file. So basically, it replaces the current process. When you run one of these, it replaces the current process. Um, and this one specifically, I'm using the date file. It gives the date. So and that's going to be. I'm going to show you where that's at. So I'm using the this xl, and I put the path, which is bin, and the name, and that's the file. This is the name of the executable file, and then that's the end of the arguments that are passed. So, like if you had a hello world program and you compiled it, you would put hello world here. It just runs. It's a program. This executable already exists inside the Linux terminal now. Um, so I have a bunch of date functions. Here's another one. This one I created a hello world program and passed in some environmental variables. I'll explain that when I get to it. And I also have one where right here, this one I demonstrate the binary calculator. That's also in the it's in the user bin, which is very similar to the bin directory. I mean, just at first glance, it looks like the same, but they have different. The user bin is more like user programs that the user would install, and the bin program is more of what the operating system uses. So this is main, and so all these functions work. Um, so I just uncomment. So I'm going to demonstrate this one first, execl, and then the second. So basically, I create two processes. The second process would run the binary calculator. So this is this is never going to be printed unless none of these are called. So this one's going to print, but I'm just going to demonstrate this one at a time. And so the parent process is going to wait for PID 1 to PID 1 2 is going to be the binary calculator. PID 1 is either going to be the date executable or the hello world file that I created. And so I'm using this is the termination status. And so it's just waiting. It waits for either one, and then it's going to exit. So so basically, the parent process creates two child processes. One child process is mainly running the date program, and the other child process is running the binary calculator program. But then I changed one for Hello World to get it a little bit more concrete about what this is doing. So there. So so I have to let's see. So I'm looking for these are executable files in the binary. Operating system will use these files. And so there's date. This is an executable file that can run. And now I'm going to look up another one. The binary calculator is also here. There. Okay. See, it looks the same. I didn't go through every file to see if it was actually the same. Um, that, so the first child was created, and then the parent process was waiting for it to terminate with the wait PID. And then this is the child's running that program, and then it gives the date. So that's all that does. It runs. It gives the date. That's what the executable file does. So actually, that's the second one because I forgot to recompile it. So that's this one, and that and now that okay, so that's that. Now see how this one has date and date in the XLP. It's because it's searching for date in the executable, and so so if you don't want to understand what that means, this is how you can look at the path variable. Now, like user local sbin, it's going to search this directory for date. It's going to search this directory for date. This is going to user sbin, and then where it is, where I just showed you was in the bin directory. I found it in here. Doesn't mean it's in other places, but this is where it found it. I just showed you. So it searches the path variable for the date executable, and then it runs the function with date. That's the first argument by convention is the name of the executable file. So I did the second one first, and now what happened was is that I didn't compile it. So when I did this before, it still ran. I had this uncommented. So now that this is uncommented, I could compile it. See, it does the same thing. It does the same thing. Now, so I called hello world this. So if when this program runs, it's going to print hello world, and then it's going to take environmental variables and it's going to print them out. Okay, so so I already compiled it. It's right here. So when I run it, I haven't given it any environmental variables. So environmental variables not set. That's the executable file. Just like date printed the date. This that's what. So I created an array, a pointer. It's an array. Excuse me, and the environmental variables is this string. These are environmental variables with period, and the null pointer is what you have to put at the end so it knows it's stopped. And then exactly, I put the incomplete path to that executable. I put the full path home and all this, and then I put the name of the first argument that runs it. Then the null terminator. This is required to put there so it knows it's the end of the argument. And in this one, you can put additional arguments, which is going to be this array of environmental variables. Okay, that's what gets passed into that file when I run this. So and so with these, sometimes you have to use the man pages and kind of play around with what goes where, because each one does something different or slightly. And they look there are similarities among all of them, but so now I uncommented it. So demonstrating this with hello world. Hello world, these are the environmental variables. So you would run a program, you can run a program like that, your own personal program, and you can do something besides this, and you can do something, you're passing in variables that this program needs. This all this did was printed it out, but you can use it in a complicated program. So now I want to show you a couple of so to get the path of like executables, you can go like which, and this, I'm going to talk about the binary calculator now. So you go which BC, and there's the path. Okay, just like which date. There's a path. It's also in the bin. I showed you the bin, um, but it's also in the bin directory. But it's also in the user one. So so if you want to find out where an executable file is in the Linux system. So I'm gonna go down here and demonstrate one of these. So argv takes an array, and so the first argument is the name of the executable file by convention. That's argv0. Argv1 is an argument. So this basically is telling the system to load the standard calculator, which has all the, it's like a scientific calculator basically. And this null, you end these with null, so it knows it's the end of the arguments. Okay, so and then I put the path to the full path with the executable, and then I pass in this array. So like I said, it loads the standard math library for BC. You'll see it in a second. So basically, the second child is going to load it. The parent process is going to create a second child, the child, And the first child it creates is not going to do anything except print this because none of these um, commented. Pilot. So the first process is running, and because I commented everything out, uh, this line should never be printed, and this no function was called, which it was, and it's not doing nothing, so it was printed out. So now now it's now the second child's running the calculator. So if you haven't seen this before, just does this. Okay, so as you see, the second child process is running the calculator. That's how that's an example of how some of the exec functions work, and they're they're really good to use with the process creation. And you don't have to create a process besides just a regular program. You can use these functions in just a regular program to create, like, to run another program while you're running the program. Um, but oftentimes you'll see them used with process creation because you want the other processes to run programs and stuff. So thank you very much.